Hybrid vehicles are very sophisticated and they're very complex. Controlling and blending this hybrid system with the internal combustion engine is a very complex situation. Making the motor generators change from motor to generator and back again, making the inverters control the motor generators, making the converter control the 12-volt system is all very complicated. It requires different ECUs, computers, or control modules that have to communicate with each other. Understanding and reviewing communications is the first step in this class, because many of the times we think we saw a hybrid problem, it was really only a communication problem that we had to diagnose. Data has to be shared between these modules, and it's carried over a multiplexed communication bus. The high-speed, near real-time data is going to be carried over a twisted pair, and that's going to be called CAN, or CAN, Controller Area Network Bus. Now, twisted pair means there's two wires and they're twisted together to help eliminate noise. The slower communications are going to be done by bean, LIN, and HVC LAN. I'll just call it HVC LAN instead of spelling the whole thing out every time. Here you can see all three on top, and the speeds are: the CAN is the fast one at 500 kilobits per second, the bean is 10K, and the HVC LAN is 17.8. And what type are they? We said that CAN is two wires are twisted together. The HVC LAN is two wires twisted together, and the bean is only a single wire, so the drivers are differential for CAN and HVC LAN, and of course the bean is a single driver. The differential type drivers means it's using both of those wires that are twisted together, the twisted pair. It doesn't simply mean that it goes in one direction on one wire and the other on the other. No, it's differential. They're working on both wires at the same time. When you start looking up information for communication problems and communication ECUs, you're going to see these symbols here. CAN is two thick wires bordering a thin, and the bean is a single, and then of course the HVC LAN is two thin ones bordering a thick one there. Now the gateway module connects the networks together by connecting the different modules that have different protocols. So the gateway module sits in the middle there, and you can see CAN, HVC LAN, and bean surrounding it with the appropriate schematic drawing there. The CAN, too thick with a thin in the middle, the HVC LAN, too thin with the thicker in the middle, and the bean being single there. And what that gateway module is doing, it's interpreting so that the CAN can understand what the HVC LAN and the bean are saying. It's interpreting so the bean can understand what CAN and HVC LAN are saying. It's interpreting so the HVC LAN can understand what the bean and CAN are saying. The gateway ECU has communication circuits built inside it, and they're going to correspond to all the different protocols. And that means bean, LIN, HVC LAN, and CAN. The different types of communication data can be shared among the communication modules after it goes through that gateway ECU. And the gateway ECU on a Prius is behind the glove box there. Now, bean communication network, or body electric area network, bean, is a single wire network that is used for low-speed communications where real time isn't so important, for any device that requires network information. Now, bean is Toyota specific standard. It's a single wire 10K kilobaud per second is what that means. And here we have a box drawing of the bean network. Now start at the top with me and we can see multiplex network, the body ECU. Underneath it on the left it says UART protocol, on the right it says bean network. Bean is really a UART, Universal Asynchronous Receive Transmit Protocol, and it's been around for many, many years. And so the Toyota people call it bean, and it's really a UART signal. And you can see the different modules that it connects to, with the bottom being the gateway module, the bottom being that gateway module, and all the other ones connected to it, they're all talking bean. And you can see if they want to leave the bean network, they have to go through the gateway to CAN or to HVC LAN. So this is the body ECU, and it's going to connect and use bean. It's a UART protocol. I know we're calling it bean, but please do not get confused. Toyota calls it bean, so we call it bean. But it is truly your everyday UART signal. ISO 9141, that is the protocol that the scan tool connects to on the DLC pin 7. It uses what is called the ISO 9141 protocol, and it is active when the scan tool is communicating on pin 7 of the DLC. It is how the vehicle is talking to the scan tool. Now, here we have a drawing of all those bean component locations. Last time we just showed you a box drawing. You can see that we have the power source ECU, the combination meter ECU. And you know what that is? That's the dashboard, combination meter. The transponder key ECU, the gateway ECU, AC ECU, the DLCs in that network, the instrument junction block. Now, these instrument junction blocks are test areas. It's very important to know where they're at. When we're doing communications, sometimes it's very difficult to get your hands or test unit on one of these modules themselves. It's easier to go to the junction block. And of course, the body ECU. Now here is your everyday bean or UART signal. Here it goes to 5 volts and we're at 1 millisecond sweep. So if your pattern looks different, you're probably not at 1 millisecond. So try it on 1 millisecond, and once you're comfortable that you have the right signal, the 5 volt signal, then you can change to any sweep rate you want. The CAN bus, controller area network 500 kilobaud, and here's a box drawing of that circuit. We can see over on the left hand side we have termination resistors, and on the right side we have those 120 ohm termination resistors. Now just start in the middle and go all the way down to the bottom, and you see gateway ECU. You can see everything that's on the CAN bus. But if any one of these need to communicate with someone who's not on the CAN, the information goes to the gateway ECU, and then it goes to bean or AVC LAN. And on each one, you can see that it has a CAN high and a CAN low. On each one, it has a CAN high and a CAN low. That is that twisted pair of wires. So for anyone to talk on the CAN network, they have to have a twisted pair of wires. Don't forget they have junction connectors on those also. Here we have our CAN component locating picture. You can see we have junction connectors number 1, skid control ECU, power steering control ECU, steering sensor, gateway ECU, the ECM, that's the engine controller, the hybrid control ECU, and junction connector number 2. You can see those junction connectors are very important when it comes to testing. Now here's our CAN signal. This is not a waveform from a scan tool. This was drawn. You can see we're on a 5 volt scale. We have CAN high and CAN low. Now, both idle at 2.5 volts. Idle means that no one on the bus is talking. And that means CAN high, CAN low, that twisted pair of wires, they're sitting there idling, not talking, at 2.5 volts. Right there. Now when they start talking, you can see they become the mirror image of each other. CAN high stops at 2.5 and goes to 3.5. It stops, it's no longer there at 2.5, it's jumped up to 3.5. And CAN low is no longer at 2.5 volts, it is now at 1.5 or 1.5 volts. And you're going to see a complete series of these high, low, this CAN high, CAN low, changing voltages when the signal's talking. Here's a DSO waveform pattern. You can see they idle at 2.5. That's when they go together. When they go apart, the system's talking. CAN high goes to 3.5, and CAN low drops down to 1.5. Now, CAN is for near real-time data. It's used in circuits that require high-speed data, like when the driver is attempting to enter the vehicle. He doesn't want to jerk on the doorknob, on the door handle, and then wait for a slower communication network to open the door. So CAN is high speed. A door lock is a very simple thing, but the customer would be upset if he couldn't get in his vehicle. But what about when you're trying to run an electric motor at 12,000 RPM? You need CAN communications in order to have near real-time data. So it's used with other protocols, so the vehicle operation is going to be done in a very timely manner, seamless to the driver. He wouldn't want to wait for any of the communications to recognize his key fob to unlock the door, and he certainly wouldn't want to wait for the electric motor communications to recognize that he stepped on the throttle. So CAN is for that real-time stuff. Now, here's an example. Over on the left, we're pointing to a key slot. You can see there's different things in there. The transponder, the key amplifier, card unlock, warning switch, halfway switch, full switch. So we're just talking about a rectangle hole in the dash there. Now the key must be fully inserted in there for the transponder key ECU to see it. And that's another computer there. The transponder key ECU communicates on the bean network. And you can see that the power source ECU, the transmission control ECU, multiplex network for the body ECU, and the gateway ECU are on the bean network. So when the key is inserted into the slot fully, the transponder key ECU tells everybody on the bean network to wake up. If it needs to talk to the power ECU in a different circuit, it uses LIN. Now the transponder key ECU also communicates on the bean as well as the LIN circuit. Now this can be for redundancy or something that Toyota's doing proprietarily. But one thing you're going to learn about this diagnostic troubleshooting class for hybrids is that there are a ton, just so many diagnostic trouble codes. So if there was something wrong with the LIN or the bean, we would have a diagnostic code pointing to either or. Now the skid ECU communicates to the hybrid ECU on CAN. And we're going to talk about the skid control. We're going to talk about the power source and the hybrid ECU individually. But here you can see that the skid control ECU and the hybrid ECU, that's braking, vehicle stability, electric motor operation, regenerative braking operation. It all has to be done in near real-time operation. The HVC LAN is the audio visual communication. It is local area network for the LAN section. The HVC LAN is a twisted pair differential network that connects the audio and the visual devices together. It basically is for anything that's audio or visual, and that means the information system on the dashboard. Now LAN drives the display that tells you all the reports that come from that information LED screen on the dashboard. It's involved with starting and controlling the system in no function whatsoever. It has nothing to do, HVC LAN has nothing to do with starting or controlling the hybrid vehicle systems. And you can see that HVC LAN locations, and you can see there's less ECUs on there. It's the navigation. It's the multi-function display, that information system. It's a gateway, of course. And then, of course, the audio head unit has nothing to do with anything that controls the hybrid system. And here it is. The navigation, the audio head, the multi-display, and then, of course, gateway to go to CAN and to bean. And you think, why would an audio have to talk to a hybrid controller on the CAN circuit? Well, the CAN circuit is part of the hybrid controller, and the hybrid controller talks and tells the multi-display what's happening in the hybrid system. Are we on ICE only? Are we on ICE and electric motor? Or are we on regenerative braking? So that's why they're connected through the gateway module. Diagnosing communication faults. If your shop has a scan tool that has the capabilities of ping, go ahead and use it. That is a great function for diagnostics. If your scan tool pings, ping. Now, the thing that most of us are going to live with is diagnostic trouble codes. Diagnostic trouble codes are going to help point us in the right direction when there's a communication problem. Those are the 4-digit codes. The 3-digit information codes are going to offer more specific information about a problem. Now here's a U0293, lost communications. That means it says it's lost communication between the hybrid ECU and the skid ECU. Doesn't say anything. Doesn't mean that the hybrid ECU isn't talking, or skid isn't talking, or wire's broken, or connectors. Doesn't say anything. It just says, hey, there's something wrong. So if you had the information code, if your scan tool will pull up information codes, you have the same code, U0293, lost communications, and then you have the information code of 152. And that offers a lot more information. CAN communication problem between the engine ECM and the hybrid control ECU. The problem is retrieved through the SIL line, and that SIL line is that 9141 protocol we're talking about on pin 7 of the DLC where the scan tool talks. Since there isn't any CAN communication, there's something wrong with the CAN communication bus, that the way you got this trouble code is through 9141. Now that is ingenious. That is absolutely the greatest thing. Why? Communication problems can be busy. They can keep you tied up for a long time. So here we have a problem on the communication bus. That means your scan tool can't talk to the communication bus. So the gateway module decides to send this code about the CAN bus out through a different protocol to the scan tool. Now, the first step, hey, pull a DTC. And then if you can ping, ping. And then if you have to work on this 152, you can go right to pins 6 and 14 at the DLC and look for the correct pattern. If you have the correct pattern, then you're going to have to look up TSBs to see if there's some programming that you need for one of the ECUs. If you don't have this pattern, there's no signal at all, you're going to have a situation of no signal, the signal stuck high, or the signal stuck low, meaning that it's always in one state or it's not there at all. Use a vehicle-specific schematic, disconnect each ECU at one at a time, and look for the signal to return. That is grinding it out. That is really, really grinding it out. You can go to those junction connectors and see if you have different signals from different modules. Or you can go with your DSO to the individual ECMs at the junction connectors or at the ECUs, whatever suits your fancy there. Now, if you're at the ECU, you're going to be digging around. If you're at the junction connector, you're at one location and you can test every ECU that's on that junction connector. But if you have to go to the individual ECMs, you have to go there. All right? So communication. All communication protocols are diagnosed the same way. Pull codes if possible. If you can ping, ping. Look for the correct signal that comes from that bus, the protocol for that bus at the DLC. the possibilities are going to be normal signal. You're going to have a normal signal. And you go, wait, I got a normal signal at the DLC. Well, that doesn't mean it's getting to every module. You could go to the joint connector. Say, well, I got a normal signal at every joint connector cavity. Now you got to go to each individual ECM. But remember, the diagnostic code led you to one or two ECUs. You can have the signal hung high, meaning it's high all the time, it's not moving, or low. And that diagnostics is very similar to normal signals or no signal at all.